Hello everyone. I want to review a few topics. I want to talk about first the XY plane. I want to review how to plot points. Then I want to go over the distance formula. And finally the midpoint formula. So these are the topics for this video. So let's start with the XY plane. So recall that the XY plane consists of two axes. The horizontal line is called the x-axis. So this line right here, you can see these arrows mean that the line goes on forever in both directions. In this direction and also in this direction. And then this vertical line right here, this is the y-axis. And it goes on forever, upwards and downwards. And these two lines, you can see they're perpendicular. They make 90-degree angle. They're called the XY plane. And you might also see this as the Cartesian coordinate system. So you can call these two lines either XY plane or the Cartesian coordinate system. It doesn't matter. So what we're going to do is we're going to first talk about what these two lines, how they break up the plane, and we're going to talk about the positive x-axis and the negative x-axis, and the positive y-axis and the negative y-axis. So first off, you can see that I have four pieces of a plane. I've got this section, this section, this section, and this section. Well, this first section here, right here, we're going to call this quadrant 1. And then this section is quadrant 2. This one is quadrant 3. And this last section is quadrant 4. In fact, I can erase all of these numbers. Maybe that'll make it a little bit easier to see right now. Just get rid of those. You can see that we've broken this plane into 4 pieces. Okay, so there are 4 quadrants. Something else I want you to notice is that we can break the lines into pieces as well. What I had before, let me erase these pieces now. You saw that I had on each one of these lines, so we have this x-axis. What I did was I put a bunch of tick marks. These little lines here are called tick marks. And from this middle portion right here, going in this direction, I labeled these as 1, 2, 3, 4, 5, and so on. And then I also had some tick marks over here. In fact, let me try to make them a little more evenly spread. Okay, so -1, -2, -3, and so on. So this piece right here, now this is going to be 0, and anything past 0 on the right of 0 here is called the positive x-axis. That's where you have your positive values on your x-axis. Now this piece is called your negative x-axis. is where all the negative numbers on your x-axis belong. Now remember, these lines go on forever. So this way you're going to -6, -7, all the way to -infinity, and then here you're going to have your positive numbers. We can also do this with the y-axis. So we can talk about the positive and the negative y-axis. Let me fix this a little bit. Okay. So I'm going to draw some tick marks here. 1, 2, 3, 4, 5, 6. This piece is going to be similar to the positive x-axis. We're going to call it the positive y-axis. So this is the positive y-axis. Here you're going to have 0, then 1, 2, 3, 4, all the way to positive infinity. So this whole portion of the y-axis is called the positive y-axis. And then of course you have the negative y-axis. And I'm going to put this one in blue. So this is the negative y-axis. Now this guy right in the middle, he's called the origin. So these are all the pieces of the graph you want to know. Your quadrants, quadrant 1, 2, 3, and 4, which go in a counterclockwise fashion. And then the pieces of your x and y axis, the positive x axis, the positive y axis, and the negative x axis and the negative y axis. So make sure you know all of those pieces. Okay, now let's talk about plotting points. I'm going to write some points that I want to plot. So plot the following. I'm going to give you the first point. Let's say 4, 2. What I think I'm going to do is I'm actually going to make this graph a little bit bigger so you can see these numbers a little bit better and it's easier for us to plot. So let me just, this little red dot there, okay, got it. Let's make this a little bit bigger. Okay, that looks pretty good. Now, this number here, this first number, you see I put a parentheses 4, 2. This is called your x coordinate. And this number 2 is called your y coordinate. So what we're going to do is we're going to start with the x coordinate. We're going to find 4 on the positive x axis. Remember that this horizontal line is your x axis, and this portion, see my hand moving here, this is the positive x axis, and we find 4. So where there's 4, I'm just going to draw like a little dotted line here. And then we're going to find 2 on the positive y-axis. So here's 2, and I'm going to draw a dotted line. And where these two lines cross is where we're going to put our point. Okay, so we're going to get rid of this dotted line now. So this is 4, 2. Let's do another one. Let's plot the point. So we plotted 4, 2. Let's do 3, 5. Okay, so 3, 5. We start with the number 3, which is here. Find the number 5, and we draw lines and see where they cross, and you can see they would cross right here. So 3, 5. How about the point -1, 3? So you can see these 2 points lie in the first quadrant. That's something you might see on your homework. What quadrant does the point 3, 5 lie in? You would say, oh, that's quadrant 1. So the point -1, 3. This time we have a negative number for the x. So the x coordinate's -1, and then we go up 3. So I know these numbers are kind of in the way here. Let's make them a little bit, let's move them over a little bit. So 1, 2, 3, 4, 5. So -1, 3, here's -1, here's 3, so it would go right here. How about -2, -2? So that is going to be in the third quadrant. We're going to find -2 for the x and -2 for the y. You can see that the point will be right here. Okay, let's put a point in the fourth quadrant. Let's go with 5, -4. All right, so we find 5 on the x-axis, and then we find -4 on the y-axis, and you can see that right here is our point. That's in quadrant 4. Something to notice is that in quadrant 1, the x and the y's are both greater than 0. In quadrant 2, your y's are greater than 0 and your x's are less than 0. In quadrant 3, so any points here, you can see both of them are negative. So you have x's are negative and y's are negative. And then in quadrant 4, your x's are going to be positive and your y's are going to be negative. Let's plot some points that aren't in quadrants. They're actually on the x or the y axis. So let's plot 2, 0. I'm going to give you 4 points. I want to see if you'll be able to figure these out. 0, 1, let's go with -2, -2, comma 0, and then let's also do 0, -4. Students tend to get confused with the ordering here. So let's just follow the definitions carefully. 2, 0. This is the x coordinate, so we find 2. And then the y coordinate is 0. And 0 means we don't move up or down. So at 2, this is where we're going to put this point. And then you can see 0, 1. Well, that means the x is 0, so that means I don't go left or right. I stay right at the origin, and I go up 1. So this is 0, 1. And 2 more. We have -2, comma 0. So this is the x. We go to -2, and we don't go up or down. So -2, 0. And then the last one is 0, so we don't go left or right, and we go down 4. So 0, -4. The point 2, 0 is on the positive x-axis. Be careful here. It's not in quadrant 1 or quadrant 4. It's on the positive x-axis. Then you can see that this point is on the positive y-axis. -2, 0 is on the negative x-axis. And the point 0, -4 is on the negative y-axis. So if I ask you what quadrants these points are in, you're going to say they're not in any quadrants. They're actually on the axes. And you say positive. I might ask you positive or negative, and you say, oh, this is the positive, and this for this point you're on the negative x-axis. Okay, let's move on. I think we've got plotting points down pretty well. Now I want to talk about the distance between 2 points on the graph. So let's scroll down here. So how do we find the distance between 2 points? Let's start off with an easy example. So right here, I'm going to give you the X and Y axis again. And what I'm going to do, let's just draw some tick marks. I'm just going to do a few of them. So let's say 1, 2, 3, 4, 2, 3, 4. I think that's enough. I'm going to give you 2 points. How about this point here and this point here? First off, can you tell me what these points are? Just looking at them. Well, you'll see that this point is 1, 0, and this point is 4, 0. And let's say P1 is 1, 0. This is going to be my first point, and P2 is 4, 0. And I want to know what's the distance between these 2 points. The distance between P1 and P2. Well, what you're going to do is you're just going to see how many steps you have to take to get from this point to the other one, right? So 1, 2, 3, you have to take 3 steps. So I would say the distance is 3. Okay, that's not hard. And you can see 4 minus 1 gives you 3. But I also have a y coordinate. But 0 minus 0 is 0, so we're not really worried about that. We're going to think about moving left and right on the x-axis. If I move these 2 points up, so let's say instead of these 2 points, oops, there we go. Let's say I gave you the points 1, 2, and 4, 2. How would you figure out the distance between P1 and P2? So 1, 2 is the point right here. 1, 2. And then 4, 2 is right here. You can see that you could make a straight line between them, and it would be exactly the same idea. It's the number of steps you would have to take to go from this point to the other point. And you see you just need to take 3 steps. So it's the same thing, it's equal to 3. Now let's put the points above each other. So let's say instead of these 2 points, I give you, let's say 3, 2, and 1, 2. So 3, 2, and sorry, let me change that. So I want to fix, I'm going to fix the x. So I'm going to say this is 3, 1. So this is P1 and this is P2. I want to know what's the distance between these 2 points. So what is this length in between the 2? And you say, oh, I just have to take 1 step to get between P1 and P2. So you say the distance is 1. Now when we talk about distance, we're not going to talk about a negative distance. So it doesn't matter if you use P1 to start with or P2 to start with. You're always going to be taking 1 step to get to the other one. So that's not hard. So distance is going to be how far you go left or right or up and down. But now let's talk about points that are not in a line. How can we find the distance between those kinds of points? So I'm going to do something a little bit trickier. So let's say we have the points 1, 1. So I'm going to call that P1. And then let's go with 4, 3. This is P2. I want to find the distance between these points. Well, how we're going to measure the distance is we're going to measure how far left and right we have to go and up and down. This distance, which I can call D, Well, you can think of it as being the side of a right triangle. And we know that if we have this side, which I can call x, and this side y, x squared plus y squared is d squared. So we need to figure out the length of x and the length of y. Now this is a problem that we just saw. So when we had a point here, we would just subtract the x coordinates. So x is going to be, we're going to subtract the x coordinates. And then for y, to get that distance, we're going to subtract the y coordinates. And it doesn't matter the order that you subtract these coordinates. So to get from 1 to 4, you can see you take 3 steps. So this is going to be 3. To get from this point up, this point, so we go from 1 to 4, this is now 4, 1, this point right here, here's 1, 1. If you move 3 steps over, you get 4, 1. Then if you go up, you can see that we take this 1 and we subtract the y coordinate here. This point is 4, 3. So 1 minus 3, that's 2. So you can see that x is 3, y is 2. And I'm going to give you a formula for this to make it a little bit easier. So to find d, we take the square root of both sides. So d squared is x squared plus y squared. If you take the square root, you get a plus or minus x squared plus y squared. But remember that distance, we're going to make that a positive number. So we're just going to take the positive square root. And so for this particular example, this is going to be the square root of 3 squared plus 2 squared, which is 9 plus 4, which is the square root of 13. That's going to be the distance, the length of this side here of this triangle. Now how can we make this a little bit easier where we don't actually have to draw every single time? We're always going to use a triangle, so I'm going to give you a formula for the distance. So this is the distance formula. Suppose you have 2 points, P1, I'm going to label this as x1, comma y1, and P2, which is x2, comma y2. The distance between these 2 points, you'll see it labeled as the distance, parentheses, P1, P2. This is going to be the square root. What you're going to do is subtract the x coordinates and square them, and then subtract the y coordinates and square them. Again, it doesn't matter how you subtract these two, or these. So whichever points you have, you can label either one of them P1 or P2. And you can see this is derived from the Pythagorean theorem, because you have exactly what we have here. And how we found this x and this y was we subtracted the x coordinates and the y coordinates. So now we can use this formula. We don't actually have to draw a triangle every time. And we can use this formula for points that aren't in quadrant 1. So if we use something, if we have points like, let's say, we have -2, 1, and maybe 2, 2. And I want to find the distance between these 2 points. We can use this distance formula. Okay? So let's try using this with 2 random points. So let's find the distance between the points 4, 8, and -1, -3. All right, so let's write down the distance formula. Let's also figure out which point we're going to label P1 and which point we're going to label P2. It doesn't matter, so I'm just going to say this one's P1 and this one's P2. So the distance between P1 and P2 is equal to the square root of x1 minus x2 squared. I'm just writing the formula again. Y1 minus y2 squared. So this is the square root. This is x1, this is y1. This is x2, this is y2. So it's going to be 4 minus a -1 squared plus 8 minus a -3 squared. We get 5 squared plus 11 squared. We want to take the square root. This is the square root of 25 plus 121. I'll put that in my calculator. Square root of 146. Now that number is even. I think I'm going to leave it just like that. Yeah, 146 is even, but this breaks into 2 times 73, and I think 73 is a prime number. I think it's fine to just leave like this. So the distance between these 2 points is the square root of 146. Let's try another example. Let's find the distance between the points 4, -2 and -3, -2. Just use the distance formula again. So we're going to let P1 be 4, -2 and P2 be -3, -2. The distance between P1 and P2 is the square root. Okay, we're going to subtract the x coordinates. So this is x1, y1. Oops. This is x2, this is y2. So 4 minus a -3 squared. This one minus this one plus a -2 minus a -2 squared. This becomes the square root 4 plus 3, which is 7. So 7 squared. And this is a -2. This becomes a plus 2. So this is actually 0. So we get the square root of 49, which is 7. So the distance between these 2 points is 7. And notice that the y-coordinate is the same. So since the y-coordinate is the same, actually these 2 points are on a horizontal line. So you just have to move 7 over. So we can actually kind of sketch this. So we have -3, -2, it's right here, and then 4, -2. And you can see to get from this point to this point, you got to go over 1, 2, 3, 4, 5, 6, 7. So it is indeed 7.